Good morning, ladies and gentlemen. It is my honor and privilege to welcome you all to this significant occasion, the launch of the report titled Charging Ahead, Transforming India's Lithium-ion Battery Recycling Ecosystem, developed by India Cellular Electronics Association in collaboration with Accenture. This report sets the stage for a bold vision, enabling India to unlock a $3.5 billion opportunity, create over 40,000 green jobs, and emerge as a global frontrunner in sustainable battery recycling. We are deeply grateful to each one of you for joining us today as we collectively explore the policies, innovations, and collaborations necessary to build a formal and circular economy battery recycling ecosystem in India. As a housekeeping rule, I request all dignitaries and media personnel present here to hold their questions till the end of the conference. May I also kindly request all attendees to switch their mobile phones to silent mode so we may proceed without any interruptions. To mark the formal commencement of this important occasion, I would like to invite all our esteemed guests on stage. I would like to welcome Mr. Sandeep Chatterjee, Managing Director, Accenture Strategy and Consulting, on stage, please. I would like to now invite Shri Amit Verma ji, Director, Circular Economy Cell, Economics and Finance Cell, ETL. I would like to invite Shri Pankaj Mohindroo, Chairman, India Cellular Electronics Association. I would like to invite Dr. Sandeep Chatterjee, Senior Advisor, Cell. I would also like to invite Ms. Yutika Puri, Scientist, E, Central Pollution Control. To set the context for today's discussion, we now invite our distinguished leader whose commitment to India's electronics manufacturing sector has been both pioneering and steadfast. Please join me in welcoming Shri Pankaj Mohindroo, Chairman ICEA, to deliver the opening remarks.
Good morning, everybody. Sandeep, great partnership I think we are having. Everybody is eagerly looking forward to the report. Welcome, Amit. DT Ayog, of course, I don't have to state how critical it is in the scheme of things. I think India needs a great mode of planning, and this is a very important subject. Dr. Sandeep Chatterjee is our friend, philosopher, guide in this area of sustainability. He has guided us, and I've always greatly impressed by his tremendous patriotism and zeal for the country and to take it forward, especially in this area. And welcome, Yutika. So I will mispronounce your name, Yutika. So my central message for sustainability has always been that it is not getting imposed on you. It is one of the greatest economic opportunities for entrepreneurs, and I think this is a message which is increasingly finding a very good place in the minds of Indian entrepreneurs, and we see the revving up of the sustainability industry as such. We are not, not getting completely guided by Europe's extreme view on certain things. Mr. Yadav, Director of CBC. First, let me talk about lithium-ion batteries. We have, under the phase manufacturing program, and before that, when the Nokia ecosystem was coming up, we have built a very big assembling industry for batteries. My estimate is that just electronic batteries, we are doing about 400 million plus. It's a very large industry, and there are more than 100 players packing just for electronics. After that, there is this new electric vehicles and solar, where batteries have come in. In the solar policy making, now where we have achieved great competitiveness and the supply chain is building, there is a new policy which locks in the battery storage, which is that we have to have 10% of battery storage. The developers, and it has an impact on tariffs. So that's a very good policy. And because of the large solar power production, the demand for batteries will increasingly go up because solar, unfortunately, is only during the day, during a certain period. And it is becoming so competitive that even with storage, I think as the storage industry becomes more and more competitive, it has become increasingly competitive. We will have solar plus storage also at a competitive. And that is becoming an enterprise in itself. Electric vehicles are also taking off in the country, so we have very large lithium-ion cells, and it has critical components: lithium, cobalt, nickel, manganese, and others. The battery technology is evolving so rapidly, and very large investments are coming in manufacturing also. So we are consuming a lot that is rapidly increasing, 30, 40, 50% CAGR, unprecedented growth. And we have now started manufacturing cells. A very large plant is coming up close to Delhi. Other plants are coming up. You would know that there is a PLI for advanced chemistry cells. So that is also happening. So the whole ecosystem is going up. On the recycling part, of course, I'll not talk too much about it. I'll leave it to Sandeep to take you through the details of the report and what an incredible opportunity it is to have the. Can you keep quiet, please? The people at the media desk. Thank you. That I'll leave it to Sandeep. Now besides that. I want to announce two initiatives which we are taking. We'll be circulating one of them, the Venture Access Labs, which is an important accelerator for innovation. You know the details about it. And the second thing, which I was discussing with Mr. Yadav also, is the CSPE, the Center for Sustainability for Pure Earth. This is an initiative we are starting for sorting out the parali issue, biomass issue, which creates this big cloud around Delhi and North India and parts of Pakistan around October, November, when the farmers are burning the parali. And we will announce what we are doing in about 4 weeks, what this outfit is all about. Dr. R.S. Sharma has agreed to be the patron of this, so we are very pleased about this. I'm going to request Sandeep also to advise us on that. And we have seen some incredible economic benefit from parali, which people think is a waste and farmers are burning it and so on. So you will I can't promise you today, but we are working very closely with MNRE and PMO that maybe by the end of 2 or 3 years, you will not have this big clouds around Delhi on October, November, and also in other parts of the country, especially in North India. Parali is burned all over the world. It's burned in the US also. It's burned in Europe also. It's burned in Pakistan, of course, is the worst affected because whatever great initiatives we took in Delhi, like CNG, etc., diesel, this thing, they did none of it. So their cities are absolutely choked. They are in much worse condition than us. And because the wind blows like that, so finally we'll have to, sit down with them and also to sort it out. We will be sorting out our own issues maybe in 2, 3 years' time. But so I thought because the audience is in a very sustainability mind today, so I thought I'll also announce this. And thank you very much, all of you, for coming here and supporting ICEA. We are completely dedicated to sustainability. And when in fact, my MBA thesis paper was on sustainability. It was not on toothpaste or soap, which usually most MBAs do. So I'm personally very wedded to it. And any improvements in our operation as far as this is concerned, we really appreciate your feedback. Thank you very much.
Thank you, sir. We now move on to the core of today's event, the presentation of key findings and recommendations from the report. I would like to invite Shri Sandeep Singh from Accenture to present the roadmap that the study outlines for transforming India's lithium-ion battery recycling ecosystem.
Good morning, everyone. Respected members of the dais and my friends in the audience. First of all, I would like to express my heartfelt gratitude to ICEA for giving us the opportunity to work on this study of national importance, which is about the lithium battery ecosystem. It's a big moment for us. The team has been working on this report for the last 7-8 months now, so it's been a journey for us to reach this far. And I would also like to thank all the participants who have supported the study in the form of interviews, discussions, consultations. We couldn't have arrived at the insights that I'm going to share today without your input. So first of all, a big thanks to everyone who has participated. Now, what I intend to do in the next 20-odd minutes, 25 minutes, is really give you a sense of what are the big messages that we have seen in the study. What are the big findings that we are coming up with in terms of what the data is telling us. Our endeavor was really look at some rich data, come up with evidence-backed insights which can inform the way we can think about how do we capitalize on the growth that we are seeing in the lithium battery ecosystem. I'll spend about 5 minutes talking about the context. I think it's important for us to be all on the same page with respect to the context. What are the market dynamics? Which parts of the value chain does the country kind of operate in? And then what are the gaps? What are the opportunities in terms of really where we can make a difference? So I'll want to talk about all of that, but as I said, I'll spend some time really setting the context as well, because this is a complex ecosystem. It's a fragmented and complex ecosystem, so we need to understand the roles, the stakeholders, the current realities before we even talk about the interventions. So with that, let's get started. This is a quick overview of the report in terms of who are participated in this. As I said, this is not an isolated study. It's a consultative study wherein a lot of stakeholders have fed into the numbers, into the insights, into the ground realities, which probably are best known when you talk to the participants who are working on the ground. So there have been multiple consultations, 15 plus interviews and discussions that we have had with recyclers, manufacturers. We have also had multiple discussions with ICEA and other stakeholders. And what you see here on the side is just a validation of the fact that, as I said, it's coming in the current form based on a lot of input and not really different. That's one that I really want to talk about the business. Now, let's turn our attention to the broad context. What are we even talking about? So I did touch upon the fact that we are going to witness a big demand increase in the lithium battery ecosystem. As it stands today, the total demand for lithium battery in the country is about 23 gigawatt hours, and this is expected to grow to about 73 gigawatt hours by 2030. That's a significant chunk. And where this demand is going to come from is going to vary depending on the application for which the batteries are going to be used. Some of it is going to come from consumer electronic batteries, some of it will come from electric vehicles, and others will come from stationary vehicles. So different segments of the applications are going to see different types of increase in the demand. EVs, for instance, are going to witness a significant demand. So we talk about the fact that 40-50% growth is what we are witnessing in space. So this is going to pick up in a big way. But then the next question is, what are the implications of this kind of an unprecedented demand that we're expecting to see in the next few years? Two implications very critical for us to take note of. First, it has an economic implication. Because a lot of the battery systems that we're going to see in the form of demand do rely upon a lot of critical active materials like lithium, cobalt, etc., which currently need to be imported. So it leads to a significant import exposure of almost about $5 billion. That's one thing that we need to be aware of as we think about the economic implications. And then, of course, there is also an implication in terms of the environmental impact. As we see the demand surging for lithium-ion batteries, it also means that there is a complete demand or a complete supply of waste that will come out of it. Now, how do we handle that? It is hazardous waste, and there has to be a thought in terms of how are we planning to handle that kind of volume of waste which is going to be generated from this demand increase that we are expecting over the next 5 years. Now, the good news is that this is not a journey that we are starting from scratch. There is already a lot of interventions, a lot of policies, a lot of actions that have been taken for us to be able to capitalize on this expected demand. So, for example, critical minerals mission, which got introduced 2 years back, is one such step. We all are aware of battery waste management, which talks about how ICEA needs to come into play, extended use responsibility needs to come into play with respect to the downstream handling of battery waste. So those are some of the things which have already happened. Equally importantly, the battery waste management is also talk about the targets with respect to how much recycled content needs to go into this entire lithium battery demand that we are seeing. These targets vary by the different types of batteries. So, for instance, if you're talking about, let's say, consumer electronics batteries, the targets are expected to rise up somewhere from 5% to about 20%. From 2027 to 2030. Similarly, for stationary storage, the guidance is somewhere around 40% by 2030. Now, the point really is that if these are the targets, we really need to start thinking about how are we currently positioned with respect to really our ability to meet these recycled content targets. And I'll touch a little bit about that as I move forward in the presentation. But those are some of the considerations and the fact that there are already interventions in place, there are already policies in place which are nudging us in the right direction with respect to really capitalizing on this demand increase that we're witnessing in lithium batteries. Now, before I really get into the specifics of the numbers, it's important for us to be, at a high level, be aware of what is the large ecosystem, what is the value chain that we're thinking of, what is the value chain that we're talking about. Of course, at the upstream end of the value chain, there is extraction, there is mining of minerals, there is refinement, there is synthesis of materials. We move further down into the value chain, that is where the battery manufacturing, component manufacturing starts. And still further downstream as we move forward in the value chain is where the assembly starts to happen before it starts to become like a completely ready to use battery, which then goes into multiple applications. And if you go further down into the value chain, there are obviously considerations with respect to how do you deal with the end of life batteries once the battery reaches the end of its life. How do you really bring it back into the productive value chain? What really happens to the scrap? How do you really start to process it? In some part of it goes into the mechanical recycling, wherein it gets crushed and transformed into black mass. And then subsequently, this black mass gets fed into hydrometallurgical recycling, wherein the extraction of valuable metals happens. So this is the end-to-end flow of materials that typically happens. And at the point also is that as a nation currently we are not probably operating in the same maturity across the value chain. Our presence is more towards the downstream parts of the value chain, which is where the assembly happens, which is where the usage happens. Some of it is really about the collection and really take-back programs and stuff. But the upstream parts, where the extraction of minerals happens, where the actual manufacturing happens, is the space where we currently do not have a lot of presence. And that's one thing that we need to be aware of as we start to think about the opportunities that we have ahead of us. Now, this is a very high-level view of the typical activities that a lithium battery value chain ecosystem would entail. But now let's turn our attention to something more specific. I said that we do not have presence across the value chain. Our presence is more limited towards the downstream parts of the value chain, which is where the assembly happens, which is where the usage happens. But let's talk about some numbers. Now, if you think about the total tonnage of battery waste that gets generated in a year, it's almost about 29 kilotons. That's the quantum of battery waste that gets generated every year. And by this slide looks a bit complex, but I'll try to touch upon the key elements without getting into all parts of it. But 29 kilotons of battery waste gets generated every year. And almost about 92% of this waste comes from consumer electronics like batteries. A very small fraction of it comes from stationary storage and electric vehicles at this point in time. But that's going to change over the coming years. As we move forward, of course, we know that EV batteries are going to see a significant surge in demand. So this composition of the end-of-life batteries is going to change over time. What is currently 92% is going to diminish to something like 38% over time. And the balance will come from stationary storage and electric vehicles. So that's one thing that we should be aware of. Now, thinking about what happens to this end-of-life battery waste. There are multiple pathways through which this material can flow. Some of it is still not collected as it stands currently in the situation. Almost about 35%, one-third of this goes uncollected. So that's one pocket which we need to be aware of, wherein there is an opportunity to unlock value. 35% is currently uncollected. Of the part that does get collected, almost about 80% of it gets collected through informal sector. So that again, something for us to be aware of as we start to think about the possibilities, because there are opportunities to streamline the processes, to make it more efficient with respect to the informal collection, and that's a large component, by the way, 50% is so that's the second. And now, after considering the fact that 35% is not collected, there is almost about 80% which happens through informal sector. Almost 15 kilotons out of the 29 kilotons reaches the mechanical recycling facilities, which is where the crushing and transformation into black mass typically happens. Now, what happens thereafter is almost about 6 kilotons of black mass comes out of those mechanical recycling facilities. And by the way, these numbers have been arrived at with a lot of consultation, site visit. There is no one simple source that can give these numbers. So it's a lot of triangulation, conversations, site visits, which has led to these numbers. But 6 kilotons is typically what comes out of mechanical recycling facility. And another point I want to highlight here is that the typical capacity, the stated capacity of mechanical recycling in the country is almost about 35 kilotons. So there is a consideration with respect to the capacity utilization. It's just about 20 kilotons. So that's one thing. Now, what happens to that 6 kilotons of black mass that comes out of the mechanical recycling facilities? It needs to be further processed to really extract the high-value metals, lithium, cobalt, nickel, etc. And currently, we do not have so much mature recycling facilities, the hydrometallurgical recycling facilities, which can process all of this. So almost about 25% of this black mass typically gets exported to countries like China, Korea, etc., where the high-value processing of this black mass happens. Of the part that does go into the hydrometallurgical facilities, the recycling facilities, almost about 4 kilotons gets converted into the industrial grade powder. And only about 0.4 kilotons is converted into high quality battery grade decap material. Only 0.4 kilotons. And just to remember, if you go back to the beginning of the value chain flow that I talked about, 29 kilotons was the annual lithium battery waste generation. After a lot of pathways, leakages, processing, all of that, 0.4 kilotons is what we are able to generate as battery grade decap material. And that's just about 1% of the total battery waste that gets generated. So again, I think while this diagram might be complex in terms of its visual look and feel, but the key point I want to leave you with is significant reliance on informal sector for connection. That's point number one. Second, significantly low utilization rates at the facilities, recycling facilities that currently exist, 20% at the mechanical recycling stage. That's the second point I want to follow. And then the third point is that at the end of it, just about 1% of the lithium battery waste actually gets converted into battery grade materials, which can be thought of as high value processed kind of value extraction. So the key point here is that we need to be aware of this material flow dynamic because this will inform how we think about unlocking the value across different stages of the value chain. With that, let's move to the next section. So I said that there are these targets that have already been put in place. So for example, I said that for consumer electronics, the guidance is to have something like 5% contribution from recycled content, which goes up gradually to about 20% by 2030. So that's the kind of ramp up we are talking about. I also said that for other applications, for example, stationary storage, this number is something like 40%. So depending on what types of application of battery you're talking about, the guidance on recycled content target will vary. And then I said that, if you think about the increase in demand expected in the battery, for the lithium batteries in Indian context, it's going to grow up from something like 23 gigawatt hours to 115 gigawatt hours. Let's try to bring these numbers all together. What does 150 gigawatt hour worth of demand in 2030 going to look like in terms of tonnage of materials? Again, there are simple heuristics, simple benchmarks. Something like 7 to 8x is a multiple, which is used to convert gigawatt hours to the tonnage of battery material that you need to be able to meet that demand. Doing the simple math, it tells us that there is almost about 900 kilotons worth of battery material demand that we are going to witness in 2030. And this, by the way, is not just consumer electronics. As I said, it is consumer electronics, it is EV, it is stationary storage. And each of these segments of battery utilization have their own targets. When we superimpose those targets on the tonnage of material, it gives us what is the anticipated demand with respect to recycled content. Now that comes out to something like 227 kilotons. Let's say around 250 kilotons is what that demand is. So this is the anticipated demand for recycled content with respect to the targets that have been laid out. Now I want to call out two key things with respect to how we should be looking at these targets. First, the guidance as of today tells us that these targets can be met from any type of material. So when we think about typical battery waste, there are different types of materials that go into it. Without getting too technical, there are electrolytes, there is dry weight, which is almost about 86% of the battery weight. And within that dry weight, there are battery critical active materials, which is where the actual chemistry happens. And then there are obviously other materials which come in the form of casings, the foils, the aluminum foils, plastic foils, and so on, which constitute the non-active critical materials that a battery comprises of. Now, when we think about these targets that I talked about, 227 kilotons that I talked about, this, as it stands today, can be made from any type of material. It is not necessarily mandated that a manufacturer has to only rely on active critical materials. It can even be made from plastics, aluminum, and other materials. So that's a good positive step, because we are still trying to make our initial foray into the lithium battery recycling ecosystem. So to have the provision to be able to meet these targets from any type of material is actually a good thing. That's the first point I want to call out. The second point that I want to call out is that we have talked about the demand. We said that 115 gigawatt hours transforms into 900 kilotons of material requirement, which transforms into 227 kilotons of recycled content requirement. This is all the demand side. Now let's turn our attention to the supply side. How much supply are we anticipating? So first thing first, there is already a lot of planned capacity investments that are currently underway. So whatever be the capacity today is going to increase significantly by the time we reach 2030. And if we look at all of these planned investments, planned expansions that they are in place, what we see is that we will still not be in a position to be able to meet that 27 kilotons worth of recycled content demand. We will still fall short of it. And if you think about the decomposition of the supply of recycled content material, a very small share of that is going to come from active critical materials. Just about 1 to 3 kilotons, very small, minuscule component, minuscule share of that is going to come from active critical materials. So as it stands today, it may not be a big problem that is very small, because the guidelines allow the manufacturers to meet those recycled content requirements from any type of material. But if you really think about the real spirit of circular economy business models, the real spirit of how we want to unlock value, this is also the space where the real value resides. You think about the import exposure that I talked about, $5 million. A lot of it comes from our reliance on active critical materials. So there is a reason for us to think about how can we accelerate the generation or the supply of these active critical materials, even if the provision today allows the manufacturers to be able to meet their recycled content target beyond these materials on. So that's one point. Second point is that while the demand continues to rise, where are we going to rely upon? Where are we going to source this kind of material from a supply perspective? If domestically it is not available in sufficient quantity, obviously it means that we have to rely on other countries like Chile, Argentina, China, etc., to be able to get some part of that demand, to be able to meet some part of that demand. So that also creates a lot of supply chain dependence. And given how the geopolitical environment is, given how the regulations and development every single day kind of impacts these kind of cross-border trade considerations, there is again merit for us as a nation to think about how can we make our own supply chains more resilient by becoming more self-reliant. So again, that's a consideration for us to think about. And last but not the least, I talked about value realization potential. Most of the significant value realization potential actually comes from active critical materials. Think about green jobs that can come out of it. You think about the environmental impact that you can create from all these investments and the growth the recycling ecosystem. Again, critical materials is where the maximum value resides. So the last point I want to convey here, and it's kind of a summary here, is that while 1 to 3 kilotons is not mandated, while it is not said that manufacturers can only meet the recycled content targets from just critical active materials, there is merit in thinking about how we can accelerate that. And even after accounting for the non-critical active materials, as it stands today, the current expansion plans, the current demand trajectory, the industry is not going to be in a position to meet the recycled content targets. Those are the 2 key messages I want to use on this slide. Now, that then, starts to bring our attention to what can we do to be able to accelerate the growth in the supply of active critical materials. Now, I want to talk about some of these initiatives that we have identified, but before I get into some of these, I do want to qualify some of these initiatives. First, some of these initiatives are already in discussions. There are a few initiatives, interventions, which are in early stages of implementation as well. So don't think of these 11 interventions categorized across 4 focus categories as new magic pills that can start our journey. No, it is not that. This is the master set or the full bucket of interventions that can help us unlock the full potential, with the acknowledgement that some of these are already under in the form of policy, in the form of subsidies, in the form of PILs, and those kind of things, which are already in place to be able to help us accelerate the development of the lithium battery ecosystem. That's one point. And second point is that while every country has its own growth trajectory, while every country has its own path that it takes to really, scale up the recycling ecosystem, and every such intervention or any such program has to be customized for the local context, there are still merits in thinking about what are the learnings from some of the other countries who have already gone up this journey. They may not be exactly applicable in the Indian context, but it still needs to inform the way we are thinking about our own trajectory. So I will bring some of those nuances as well as we start to think about these interventions. So that's the second point I want to make before I go to the interventions themselves. And then the third point and the last point before I actually come to the interventions is that a lot of this is interdependent ecosystem. So we will talk about how can we increase the manufacturing capacity, cell manufacturing capacity of the country. We will talk about how can we increase the recycling capacity of the country. But the two have to be thought hand in hand. They can't be independent of each other. I mean, recycling facilities won't evolve until there is an assured uptake, assured demand for the recycled product. And that won't happen till we have adequate capacity for manufacturing of lithium battery. And lithium battery manufacturers will probably be reluctant to set up the facilities till they are assured of the recycled content that they need to be able to meet the guidelines, to be able to meet the targets that are in place. So some of it has to go hand in hand. And then we'll see how the phasing out of these interventions is going to be critical to ensure that one is not moving too far ahead of the other. We don't want to move too far ahead in terms of manufacturing capacity unless the recycling ecosystem is also following suit. We can't be moving too far ahead in the recycling ecosystem if the manufacturing hasn't taken place, because then what happens with that recycled content? There isn't enough uptake in the domestic market, which then needs to be exported. So probably we are again leaving some value on the table if we don't marry the two journeys with respect to how it works. So those 3 points before we now go into the specifics. So the first one is really around how do we think about expanding the manufacturing capacity for lithium batteries. And this is a space where, as I said, there is a lot of intervention which is currently already underway. You think about the PIS scheme, there is almost a capital outlay of about $2 billion which has been earmarked to incentivize investment in manufacturing capacity for lithium batteries. So that's one big thing which the industry is already kind of tapping into. You think about some of the provisions that were made in the 2023-24 union budget. Again, there were incentives with respect to the import of capital-intensive machinery which goes into manufacturing of lithium batteries. So again, these are some of the steps that have already been taken. And the good thing also is that if we think about the journey that some of the other countries have taken with respect to how their ecosystem has evolved, there is evidence that recycling ecosystem typically follows the growth trajectory of manufacturing capacity. Once the manufacturing capacity evolves, China has seen that, South Korea has seen that, recycling facility kind of follows that because then there is an assured demand for the recycled product that the recyclers will produce. So I think this is one area where there is a lot already happening. The second thing that I want to call out is that as we think about expanding the manufacturing capacity for lithium batteries, it also means that there is going to be a lot of scrap generation in the process. For a mature organization, for a mature country, with respect to thinking about the scrap generation, there is almost about 5 to 10% of the plant capacity that gets generated as a scrap. For a country like ours, which is still in the early stages when it comes to manufacturing capacity implementation, the scrap could be as high as 20%. So how do we think about that? Now, there is merit in thinking about, is there a way for manufacturers to account for their recycle targets by utilizing this scrap generation in the process? European Union has done that with a lot of success. And this is a learning that we could adopt as well. That if there is a way for manufacturers to be able to account for the scrap generation in the process of building the manufacturing capacities for lithium batteries, there is an inbuilt incentive for them to move forward. So if there is a way for us to account for that scrap into the recycled content targets, it will only benefit the industry. That's first thing which is really about the manufacturing capacity investments. Now let's turn our attention to the recycling capacity. As I said, there are two distinct types of recycling capacity. There is mechanical recycling, which typically crushes and converts the scrap into black mass, the dry weight into black mass. This is not where the high value extraction happens. This is just the first step towards really extracting. And the capacity for this is currently about 35 kilotons in the country. This is the stated capacity. Of course, there is no single source which corroborates this number, but based on a lot of interviews and discussions with the recyclers, this is what we have estimated. So take it with a little bit of caution. It could be plus or minus a little bit. And then when we think about the hydrometallurgical capacity, where the extraction, the precious metals, the value extraction really happens, that capacity is currently about 15 kilotons. Now, we have to think about how exactly can we ramp it up, because this is where, as I said, the real value resides. When we think about the recyclers, when we had the discussions with the recyclers, what we found was that they have significant plans with respect to how they want to scale it up. 15 kilotons is what we see today. The planned capacity expansion is going to take it to something like 109 kilotons by 2020. So that's the good news. I mean, there is an intent to grow the hydrometallurgical capacity within the country. But then what the study finds is that there is almost a need for almost about $0.9 to $1 billion worth of capital outlay to incentivize this, to make it practical, to make it achievable. And that is where there is probably an opportunity to think about how can some of our schemes like PLI and some of the subsidy schemes can contribute towards that capital outlay requirement to be able to achieve this capacity expansion of something like 50 kilotons to about 109 kilotons. That's the second key message that we want to call out. Again, thinking about some of the best practices and learnings that we have seen from some of the other countries. South Korea has done this with a bit of success. China has done this with a bit of success. In 2014, they introduced some kind of subsidy schemes to incentivize investments in hydrometallurgical recycling capacities. In 2018, they kind of boosted that with some more subsidy incentives. So that has worked very nicely. And there is an opportunity for us to think about how we could replicate some of that in the Indian context. Now, still moving forward with the same focus area, the second focus area, which is around the recycling capacity, there is also a consideration with respect to the standards, the recycling standards. So when you think from a manufacturer's perspective, they need assured, credible, certified kind of a supplier, because they have to meet their targets with respect to recycled content. And currently, as it stands, there isn't any standard framework which certifies the output from the recyclers. There are different standards which are currently being deployed, but if you ask me any single standard which is like the accepted norm, still there is not a single such standard, and this is where an opportunity exists for the industry to take the lead to work with EIS to be able to create some of these standards. I mean, that will only help accelerate the adoption of recycled content. It will ensure demand uptake from the manufacturers and from the brands who then need to kind of account for this content in their final output in the form of this target that I talked about, 5% to 20% to kind of reinforce the numbers. So this is again important. Something to learn from Korea again. Korea has already implemented some of these renewable raw material certification standards with a lot of success. And at the moment these kind of standards come into play, there is a kind of an uptake which happens because the system becomes more transparent, there is more credibility, there are more certifications, and there is also an opportunity to think about how can we bring in third-party authorized certifications to be able to certify the output from the recycler. So that again will go a long way in terms of really ensuring the demand for the recycled products and supporting the manufacturers to be able to account for that product in their recycled content targets. So we have talked about the investments in the manufacturing capacity. We have talked about the recycling capacity. Let's now turn our attention to the third focus area, which is really about trade considerations. And with respect to trade considerations, two key things one needs to be aware of. One, right now, since there isn't a lot of domestically available scrap because we don't have domestic manufacturing capacity to that extent, recyclers have no choice but to really rely upon some of the imports that they need to make. And obviously, lithium battery as a substance is something which qualifies as hazardous waste. I mean, it falls under the P10904 code, which essentially means that there is a lot of scrutiny with respect to trans-border flow of materials. So if a recycler needs to ensure sufficient feedstock for its facilities and it wants to import lithium battery scrap, there are a lot of considerations. You have to achieve some kind of import permit, and there is a process behind that. So if there is a way to think about that while we are in the process of expanding the capacities for manufacturing of lithium batteries and the recycling capacities, in the process of that journey for the first few years, if there is a way to relax some of these considerations with respect to the import of lithium battery scrap, it might help the recyclers. But I deliberately want to use the word in a very controlled way because, as I said, lithium battery is a sensitive material, it's a hazardous material. We don't want to make it a norm, we don't want to make it a way of working. But only in the interim, while the two capacities are expanding, to ensure that there is sufficient feedstock for the recyclers, there is merit in thinking about how one can make the import of lithium battery scrap a little more easier. There are examples. I mean, we had a discussion with material recyclers, for example, and we learned that they already have such permits from MOEFCC. But of course, these permits have a lot of scrutiny, there is a lot of guidance. So a particular recycler cannot, for example, have more than 20% of their installed capacity be imported in the form of lithium battery scrap from abroad. So this is one consideration that we do want to call out. The second consideration with respect to the black mass. So when the scrap enters, let's say mechanical recycling facilities, gets crushed, converted into black mass, what do we do with that? Now again, the timing is of essence. It's easy to say that this needs to be deployed domestically, but the point also remains that if we don't have sufficient capacities or sufficient operating rates of utilization which can access all of that black mass, then some of it gets leaked out in the form of exports. As I was calling out in the form of the material flow analysis, almost about 25% of black mass that gets generated in the Indian context, about 1.5 kilotons, to remind you the numbers, actually gets exported in different forms. So when that happens, it also means that there is a leakage of those high-value items, high-value materials, which goes out in the form of the black mass. So what can we do to be able to really keep that within the domestic boundaries? Again, there has to be some deliberation with respect to how we regulate the export of that. And I do want to reinforce that cross-border transfer of materials with respect to lithium battery scrap or black mass is a sensitive topic. I mean, we are dealing with hazardous waste. We don't want to come up with some kind of a suggestion which makes it like a way of working for a long term. It's only a end-to-end solution, and the timing is of essence. While the domestic manufacturing capacity expands and gets to a stage where there is sufficient supply of scrap for the recycling facilities, this is a consideration to be thought about, but not a way of working. A way of working would really be that the two capacities expand in parallel with a little bit of an offset, if you will, wherein the manufacturing capacities are slightly ahead of recycling capacity. And in the interim, to be able to make sure that the recycled plants are viable, are operating economically, are operating at full utilization rates, these considerations will be brought in. And then the last pillar, which is the fourth pillar, is really about the downstream connection. So again, I'll go back to that material flow analysis that we were talking about. We said that almost about 35% of lithium battery waste, which gets generated from consumer electronics batteries, which by the way is 92% of the current battery waste generation, is not connected currently. Right? So pardon me if I'm using too many numbers because these numbers are really important. So as I said, 92% of current 29 kilotons worth of waste that gets generated comes from consumer electronics. Now, if you think about that, almost about 35% is unconnected. So that's a big opportunity area. And there are possibilities of thinking about how can we do more of consumer awareness, start to link it to more of Swachh Bharat Abhiyan and some of those ongoing initiatives to accelerate the connection, because all of it then starts to become valuable feedstock for the people. So these are some of the big interventions that we have outlined in the study. Each of those interventions has been qualified based on what impact it would have in terms of economic impact, in terms of job creation, in terms of investments required, in terms of reduction in CO2 emissions. So there is a lot of detail, but I still want to give you just a sneak peek into how we have thought about this. Now, if we turn our attention to the point that I was talking about, the industry's ability to be able to meet the recycled content. Again, to refresh the numbers, I said that purely from a demand perspective, we are talking about 27 kilotons of recycled content requirement from a demand perspective, which cut across the three types, active materials, non-active materials, and materials like oils and plastics and aluminum. If we turn our attention to just the active critical materials, what does that 27 kilotons worth of demand, expected demand in 2030 correspond to? With respect to critical active materials, it is about 65 kilotons. And as it stands today, based on all the ongoing interventions as an industry, we will just be meeting about 1 to 3 kilotons coming from active critical materials. Now, if you think about that number in the context of percentages, that's just about 4 to 5% of the expected demand. With all the interventions that I talked about on the previous slide, obviously this is going to be an uptake in the supply of active critical materials by 2030. But our analysis shows that even after all these interventions are fully implemented, this percentage of 4 to 5% is not going to go beyond 14%, let's say 14 to 15%. And that still falls short of the 20% guidance, for example, that we are thinking about. So while we do all of these interventions that I talked about, while we unlock the value in terms of economic impact, in terms of jobs creation, there is also some merit in thinking about recalibrating some of these targets. Again, I do want to call out some learnings, some anecdotal evidence from how other countries have done it. If we think about China and Korea, as I said, a lot of these capacities evolve in parallel. So as the manufacturing capacity of lithium battery ecosystem evolves, the recycling norms, the recycling capacities also kind of follow suit and kind of go in tandem. In China and Korea, for example, after they set up the first lithium battery manufacturing plant, it took them about 20-25 years to be able to put in place the guidance on recycled content target. So that's a significant lag that they had seen. There's a significant time that they allowed the industry to mature before they started, putting in place the recycled content requirements. In the Indian context, I think the good news is that we are taking a much more bolder approach. So we are not necessarily walked out with the pace that other countries have taken. Having said that, we might still want to think about how do we recalibrate this, because the ground realities, the material flow analysis, the projected investment, the capacity expansion plans tell us that within 3 years, even after the interventions are implemented, we are probably going to fall short of the recycled content target. So what are the options? Options are basically going to be a combination of multiple things. You could think about increasing the supply further. You could think about importing. You could think about recalibrating the targets. Our view is that if only we could offset the targets by about 2 years and reduce the upper cap by 40%. And in parallel, implement all the interventions that I just talked about. The industry would still be able to meet the targets with respect to the recycled content on battery active critical materials. And then I reinforce the point battery active critical materials. Now we are not talking about any type of materials. We have already done our attention to battery active critical materials where they get value recycled. And is that a compromise? The answer is no, because as I said, some of the mature countries have taken 20 years, 29 years to be able to come up with these kind of recycled content targets after they introduce the first battery manufacturing plant in the country. Us relaxing to the 2 years still means that we are doing it in 5 years, what others have done in 20 plus years. So in no way this compromise is making us any less bold. So that's one point I want to do really follow. And then if we move forward, I think I covered these points, but the point as I was sharing, that relaxing the target by about 40% and offsetting it by 2 years actually makes it viable in conjunction with all the initiatives that we just talked about across 4 areas, 11 interventions. So that's one of the findings from the study as well. And then most importantly, as we do these interventions, what is the value at stake? The good thing is that it has a holistic value realization potential. These 11 interventions implemented fully over the next 5 years hold the potential to really unlock $3.5 billion worth of value in the form of economic impact. Around 40,000 jobs is what it can unlock, green jobs, with respect to the new jobs that get created because of the investments in manufacturing capacities, the recycling capacities, and all of that. Around 75 kilotons worth of CO2 emissions can get reduced just by these 11 interventions. So the point that I want to leave you all with is that yes, there is a lot of untapped potential. Yes, we are on a growth trajectory. The demand is going to increase. Yes, we are already on our way to be able to realize this potential in the form of a lot of PLS schemes and BWMR rules, battery waste management rules, and a lot of initiatives in the form of incentives, which are currently in place. And as we continue to do that, there is evidence that we are well on our way to be able to realize this potential in a holistic way. Last point I want to make is that the whole idea of this study is to be able to give some sneak peek into what's the art of possible. For something as complex as this, there is no one right answer. There is no one silver bullet which can tell us that you do this and you can untap the entire value potential. But I do hope that it provides sufficient food for thought for the policymakers, for the stakeholders to be able to think about what would be the potential pathways. And then, of course, I'm sure we will have a lot of scope for deliberations and iterations as we move forward, as we start to think about really bringing these suggestions. So with that, thank you so much for your attention, and I really look forward to seeing how the industry takes interventions and move forward with the pathway that they ahead of us in terms of unlocking this value. Thank you.
Thank you so much, sir, for the presentation. It is now time to unveil the report, but before that, I would like to formally invite Ms. Sunita Varmaji, Scientist G and Group Coordinator, Ministry of Electronics and Information Technology. Thank you, ma'am, for joining us for the event. May I also request Shri Singhal, Strategy Senior Manager, Accenture Strategy and Consulting, to join us on stage. I would kindly request all the dignitaries to officially please launch the
President.
Thank you so much, everybody. A moment of significance captured both in word and image. This report stands as a crucial step towards building a cleaner, resource efficient, and resilient circular economy in India. I would now like to invite Shri Amit Verma, Director Circular Economy Cell Economics and Finance Cell Niti Aayog, to share a few words.
Thank you so much, and on the guys and all the participants, or I would say the change makers of the LIB industry. I would say, great to be here interacting with you all. We actually have also requested this over time study and many of because they are very familiar and we have been set up and this is very important topic. So to begin with, I was very impressive the commitment shown by the chair itself on the sustainability front. It's how the industry is there for sustainability. I think that's very, very impressive. And if there is a direction and intent for the top, I think things fall in place. Many of the things, as far as sustainability is concerned, they not make a lot of economic sense many times, but they do. They are a commitment which we have to the planet, to the future generations. So a lot of passion is required to do these things, and which I did find here, and as congratulations for that. Regarding the report, congratulations. I think it's a very, very impressive report you've created. It's a lot of very good data points, and even to read the whole report. DD itself is working on this for the last about 8-9 months now. DD's own journey on the blue economy, I'm sure most of you would know that, but just to touch upon it. In 21, Niti had come with very detailed reports on 10 sectors, and last year we again took up studies to do a review on end-of-life vehicles, tires, EVs, lithium-ion batteries, and scrap metal. Much of the things are interrelated, and there are many, many cross-sectional issues when we delve deeper into each of the sectors. Issues like GST channels, which should be constant. Issues like EPR, flow. There are simple products like plastics, where only one EPR apply, but there are complex products like ELPs, end-of-life vehicles, where 7 or 8 EPRs may apply in the same one single product. So there is complexity in dealing with all these legislations, which I view it is evolving. CBCB is building new portal, easing out the process, and as the problems are coming, many efforts have been made to ease out all the challenges which are there. So, patient participation of government, of the participant of the industry, of these actors is very much required at this juncture to make sure that our journey for sustainable growth continues and is successful. In terms of analysis, I think it's important to reiterate a bit of what we also said. The important growth areas are going to be end-of-life vehicles and grid storage energy systems, which are going to become a very important component. By 35, I think it will probably constitute 60% of all lithium-ion batteries. But today, the landscape is very different. Today, it's largely driven by collection of e-waste, and much of the lithium-ion batteries today, which are part of the ecosystem, so much of the electronics is the lithium-ion batteries are coming from the battery. So the problems of e-waste management and lithium-ion battery as of today are very, very similar. The sectors should work very closely. The value which a recycler can generate through recycling is very important. Because other than until there is money on the table, nobody is going to do it. At the end of the day, nobody is doing charity. So we need to figure out what are the various economic models which we can make it possible. EPR is one of them, but there are other subsidiary models also which can support this kind of idea. For example, power market has been announced, and the ICEA is being looked at, and the itself is now working very closely with me to come out with a carbon market mechanism for all the waste recycling streams, which can create some additional value for the sector. So that's one. There are other mechanisms also. There could be concession, there are RLIs, there are PLIs, there are many versions of it through which the government can subsidize based on how much recycling is happening. In end-of-life vehicles also, there has been some very different mechanisms which have been used. For example, giving concessions by the state governments itself for registration of new vehicles, where you can get a discount up to 25% on registration of new vehicle if you have formerly recycled product. And also by after the call by Mods and UCC, the OEMs themselves also chipped in with the announcement of discount of 1.5 to 3% more on the cost of the car if a formerly recycled certificate has been produced for basic. So I mentioned this example because I think it's an important step from the manufacturers, and it should be there in not only in vehicles but in all different streams also. When this whole ecosystem of creating an incentive for recyclers could be created. For me, I'm a great fan of governance. We should have least regulation as far as possible. We should not be going into domains where we specify each and every percentage for the manufacturers. There are many limitations in doing so. It actually may get the bottom line or the efficiency of the process, or sometimes the material is not available. So incentives which can come out or flow from the industry by their own will, I think these are the best which can make the system work. So something which should be worked on, I would say. Among the other challenges is, of course, any of the industry when we look at compare some of the best practices were mentioned by Mr. Shri, but one thing I really want to mention is that the economies of scale and the way we work at versus what where are all black masses going China, where the factories are of an order of 5x. The average size of a factory is 5x in India, recycling unit, I would say. We do a 10 kiloton kind of a recycling plant, the China would probably do it at 50 kiloton. That itself is, in our own analysis, shows that just by reaching the scale, we will be able to bring down the cost of recycling so greatly that probably many of the incentives required at this point of time will not be required. But what is the challenge in doing so? I mean, it seems very simple that somebody should invest the money, but we don't really have the raw material currently to supply also. And India itself is its own circle aspect of economics as compared to the Western world. So it's very, very important that we are able to develop some reverse logistics supply chain from the Western world back to India where we can take this forward. I think that's going to be very, very important. And, another point I would say is the whole two silos which we have started looking at the whole recycling landscape forward and inform. I think it's something which we need to stop the differentiation and try to upgrade the formal into formal recycler. Many of the schemes from maybe are already there. Mr. Salim has already worked with this for a very long time, and I'm sure that that break-even point would also come when this differentiation would stop. There is a huge workforce behind it. They cannot be out of job. There is a lot of social aspects to it. When we talk about community, let's talk about just transition. And for the sake of just transition of the community who is taking care of the waste at this point of time, we need to make sure that they are part of this whole chain of sustainability and they are able to be taken ahead. So I think that is also going to be very, very important. The last challenge, which probably I did not find a mention of that, this presentation will be in the report, is the challenges which are going to come in future with the changing chemistry of the batteries. So currently we have NMCs which are very, very profitable to do it, but the moment we go into the domain of LFPs, and which is going to be the major battery when we talk about vehicles especially, and also the energy storage, the cost economics are going to be really adverse. And unless we are able to achieve the scale which I mentioned earlier, plants which are like 5x current size, it's going to be extremely difficult for them to be profitable. So I think this whole ecosystem has to evolve together. The way we are going to source our materials within the country, from outside the country, and also how the chemistry would change and how the technology is now currently changing. It is possible that we may develop a battery which probably is sodium phosphate battery or something, right? There will be no value in that as such for somebody to generate, but we will still need to listen to it. So economics have to work at a certain point, but beyond that point, there is also part of the cost which has to be borne by the consumers by using the known principles of polluter pay and consumer pays principles. We'll have to see how it evolves. But for now, I think LFP is going to be a challenge, and that is what we have and scales will be important, and we also have been thinking of many multiple ways of how we begin with that scale. So thank you so much for inviting me here, and I must congratulate you for this very wonderful report. And at TT, I'm sure that would be very welcoming for presentation from you to our own seniors, so that much of the learnings of this can also be utilized in the policy formation which we are doing. Thank you so much.
Thank you so much, sir. I would now like to invite Ms. Sunita Verma, Scientist G and Group Coordinator, MIT, to share a few words with the August Gathering. Morning to everyone, and my first of all apologies for being delayed. I would have loved to hear the complete report summary that has been given so well by Shri and Accenture, and each and every word and the contents were so interesting. So I am expecting that the whole report is also very informative, and there are very good suggestions that can be taken, because when the report is made, it is with the stakeholders consultation, deep thought goes into it, and government always works with the stakeholders to make any schemes that we have with the maximum of impact, because each and every taxpayer's money has to be optimally utilized. And I agree with Mr. Amit Verma on that. With minimum governance, maximum of output is what is expected. So, from the BT perspective, I think we have started working on the lithium-ion batteries and the recycling aspect of it, and the circular economy for the batteries, along with the futuristic approach that replacing the lithium-ion batteries with more effective technologies like sodium ion and how to make it more efficient. So we, Government of India, has attached high priority to this notion of circular economy in lithium-ion batteries, and create the local supply chain for the materials and for manufacturing of lithium-ion batteries. Before I took charge, I think Dr. Sandeep Chatterjee has been very, I'll say, energetically taking it forward, and and he's totally sensitized with the manufacturers' challenges that are there in the recycling aspect, not only for lithium-ion, but complete e-waste that we are looking at as an industry. And some of the challenges are being trying to be addressed by the government. Some policies have been introduced, the interventions are there for both upstream and downstream for the product life cycle, where MOEFCC has introduced the battery waste management rules in 2022, and is establishing a regulatory framework to foster the recycling and retention of critical battery active materials within India. So the export of black mass is one of the concerns that has been raised at various levels in the different ministries, and that is why Ministry of Mines is also coming out with a scheme for especially recycling for various verticals to get the critical minerals and the precious materials within the country instead of black mass being exported out. And for that, with the scheme, will have right incentives for manufacturers, I hope, because this is being made with the consultation with the stakeholders for setting up their manufacturing facility, giving them enough incentives, and to a certain extent, getting the desired raw material for their manufacturing, for their extraction, recycling.
And with this, also, it is very important that the recycled and extracted material is used for as a secondary raw material for further manufacturing of batteries as well as for various other aspects like in e-waste. So BT has been working towards the development of technologies for e-waste and for lithium-ion batteries. And it is a nodal ministry for actively the circular economy for the triple sector. There is a center of excellence which has been um, created at CMET Hyderabad, especially for e-waste management. And this COE offers recycling technologies for PCB, including lithium-ion batteries, solar panels, permanent magnets, etc. And the local process equipment and machineries which are required for recycling of e-waste have also been developed. So it is a complete ecosystem that the ministry is looking at. From the R&D perspective, that we have the right technologies and the right machineries which can be taken up by the manufacturers or by the industry to set up their own facility. And with the Ministry of Mines coming out with a scheme for recycling, we are totally in sync that taking the indigenous technology, we can scale it up and set up our facilities for the in-house recycling. And today, I'm also happy to announce that the technology which has been developed for lithium-ion battery recycling has been taken up by more than 25 industries, and the number is still increasing. And since we have the complete manufacturing ecosystem, the machinery also, so the development of machines and setting up cost will be very, I'll say, low with respect to any other facility taken from outside. And I hope the report covers the complete value chain that is needed for making the lithium-ion recycling more effective, and we can contribute from the ministry side and in any efforts that are required. The COE that is established also offers the skilling and the capacity building program for again the formal and informal sector. So we are trying to bring into our ambit informal sector also, so that they at the minimum cost they can be part of our informal sector and the challenges which are faced by the informal sector are overcome. So we are working with the MSME sector, with the MSME ministry for developing various clusters where the e-waste or the batteries can be segregated and then they can be recycled and sent as secondary raw material for the manufacturers. And the partners in the cluster can become the paneled secondary raw material sources. So this cluster project has recently been started, and under this around 15,000 informal sector people will be upgraded to the formal supply chain. That is what our targets are, and I think we will get support from all the manufacturers and from our industry partners to make it a success for taking up these indigenous technologies. BT is also working with the international partners for bringing in more technologies for recycling. And some that we have developed indigenously, some which we can co-develop with other countries, so that the recycling and the complete circular economy can be taken care of in the triple sector. We also understand that the electronic manufacturing is also dependent on the high material consumption with very rare earth metals, and the rate of extraction of these resources for triple manufacturing is higher than the rate of the population. So we had discussions at various levels for how to extract the critical raw materials in a more effective and cost-effective way, because although the content of critical materials is very less, but the processing cost and the extraction cost might be more than that. But somewhere from the conservation and from the environment point of view, I think we need to take it up, and METI is supporting research in this area where we can try to bring down the cost of extraction so that the precious metals can be extracted in a better and more effective, cost-effective way. So Ministry of Mines also has come out with a list of all the 30 minerals which are identified as critical the country, and lithium is one of them. And our organization CMET has been working on the various aspects of the recycling and circular economy. I would like to thank and congratulate ICEA for this wonderful report, and I hope that we can take some inputs and we can draw some suggestions from this and take it and try to adopt in the policies that we are going to develop to make it more effective. I do understand that before recycling, manufacturing also is one of the aspects that has to be looked into, and I think that lithium-ion manufacturing also is being targeted, and it has been in the policy by other ministries. That, along with the recycling initiatives that are to be taken as a whole of a government approach with Ministry of OEFCC, Mines, and METI, we are together working on this for the lithium-ion recycling and the circular economy. So I assure that we'll be doing our best and we'll keep getting inputs from you all. And it's very, I think this platform is the right platform to not only share our initiatives, but also to get the thoughts of the manufacturers on what more is required from the government. Because I feel it's not the finances, it is the money to be put in the right direction that is what is required to make the schemes more effective. So thank you all for this opportunity that you have given.
Thank you so much, ma'am. I would now like to invite Dr. Sandeep Chatterjee, Senior Advisor, SERI, to share his perspectives on
Good afternoon, all. First of all, I congratulate ICEA and Accenture and leadership of Mr. Pankaj Mohindroo for always pioneer for taking the sustainability in forefront of manufacturing ecosystem. A few years back, they have come out with a very fantastic report. They are in circular economy. In this room also, we have now launched that. These reports are always, I've seen a lot of insights of Indians manufacturing ecosystem, how it can be improved. So I should congratulate the team for that. Since Madam Shri has already mentioned about the benefits of the thing, I am representing SERI, the USA, that is Sustainable Electronics Recycling International. We generally push the standards, and we have been recognized 47 different countries, and we have almost 50 R2 certified recycler in the country also. So lithium-ion battery, if you see our growth story and our aspiration to achieve $10 trillion 2030, where that will be 25% will be driven by digital technology. And once we are talking about digital technology, lithium-ion battery, because movable device will be very integrated part, and where lithium and battery or any rechargeable battery will play important role. If whatever they have come out with the figure 150 gigawatt hour, some reports are saying around 250 gigawatt hour. So if you are really interested to absorb that much system, we require at least 1 lakh tons of lithium, 4,000 tons of cobalt, 18,000 tons of nickel, and if the chemistry is not changed. So this is one number we have to target, and I do not see the our economy will do in the same gradient. We are seeing the gradient will be faster. So our whatever number we are talking about, it should be validated accordingly. So here I will just want to many of the things already I told. I will not repeat them. Whatever international best practices we want to learn, battery management rule is very progressive. It could not happen in the e-waste, and the battery management system was targeting the secondary raw material. E-waste rule was is there for last 1 decade. It's not because they have not taken that progressive step. But as Sandeep mentioned, that that target has to be matched with the extraction, the minerals from the waste. So there are a lot of challenges. So EPR is there. EPR is one of the important policy tools used to enter the world. 463 different items. The proven thing that EPR will help to formalize coming from the formal sector. But collection system, it is going to the refurbishers and the recycling. In US also, and in there are lots of challenges. Wiki is helping to come out with a progressive action plan. But it is not translating some of the ground. That is one thing. Second, very important thing, if you are really pushing the circular economy, we should start from the design stage. And in design, can you have the modular design standard in the battery so that dismantling will be easier? Can you have a standard chemistry so that recycling will be more comfortable, and it will be having, you do not like committee has mentioned that you have to change your recycling plant if the chemistry is changing. So who will be having so much of money to invest after 2-3 years of the chemistry? So India should look at all those standard things so that our growth story for 10 years should be uniform. Then parallelly we can change the chemistry like sodium, just mentioned. We have plenty of sodium, yes. But for lithium, nickel, cobalt, we are badly depending on our input, and we know the geopolitical equation nowadays. Another two things very recently come out in China as well as European Union. That also I should mention here. Many guys are saying that black mass cannot be kept here. But China and European Union, meaning countries, they are stocking their black mass because this is the national asset. So can we take that drastic step? As Sunita Madam also mentioned, the Minister of Mines are saying that because if you are actually investing, one way you are giving the subsidy to have a manufacturing plant here. You are allowing the black mass to go out. So both the things cannot work together. So those things we have to work on. And finally, in recycling, I should mention another thing. Only hydrometallurgy will not work. You have to talk with direct recycling. The direct recycling is cheaper, and you can have a refurbishment of the emergent study can be produced further. So we should have some collaboration with EV and also the static storage player. So how they can collaborate together So policy push should be in those areas. So that is a one few things I was interested to mention. But this type of initiative taken by ICA, I know this ICA for last almost 10 to 15 years. They're always progressive in giving a new idea to the manufacturing ecosystem to thought through so that India can progress. Because see, initially we were here for last 4 decades of our ICT strength, mostly the software service. But last 10 years, because of Pankaj's leadership, we have found that we can talk about the manufacturing. We are the manufacturers person. So our relevance in METI was not that good because we are the era of software. Now actually, it is fast tracking. METI's main thing is electronics. And if we are talking about electronics, without material, you cannot thought. Okay, so now it is the right time. Another 10 to 20 years it will be our time. So that whatever elements we can extract, we should see and we should do it here. Finally, I will be mentioning another thing. If you are talking about investing through specs or other subsidy scheme, people will be going for a printed circuit board recycling or lithium-ion battery recycling. We are talking about the five, six elements only: copper, gold, silver, palladium, or in battery, zinc, nickel, lithium, and cobalt. iPhone 16. How many elements they are using? 69 elements. And you have a list of 30 critical minerals by the list of mines. We have to promote who can invest extracting other elements as well. We should promote our research which can extract the other element. We do not know how to take back the indium from the flat skin. We do not know how to extract the tantalum from the calcium. So can you have the investment in that? Because without that, there is no replacement. See, soldering, you have replaced lead by tin. You have not replaced the indium oxide. Thin layer, indium is no longer in the model. So can you push the meditation, push the technology, coming from the other elements? And there may not be the hydrometallurgy or pyrometallurgy method. It should be an innovative way of taking, those component which is having a rich that element to segregate before recycling, so that they can be taken in another route. So I think I'm giving another job to ICA, find out those other elements, how this component will be designed. I'm happy TV was doing this for the Minister of Mines. They have invited me also for a suggestion. I have given the suggestion. The same PPR committee, whatever is done by MOEF, may not work because they are concentrating on the electronics product. You are talking about the critical mineral. So your focus should be component. So those, because the recycler, there are 400 for recycling now country, they do not know how to extract neodymium from the hard drive. They are showing that. Do you know what is the cost? And how much in 2030 will be requiring? 9,000 tons of neodymium will be requiring for magnet. So from recycler also you have to collect them. So I'm happy that cement is having some technology. So on neodymium. So those things we have to focus now, because we have already discussed about copper recycling, gold recycling, lithium recycling for last 20 years or so. Now we should change our gear. We should focus on what are the other critical minerals on which our electronics production will be stopped. Because from product you come with the component now. So now you will be requiring the material. So those some of the unanswered question I was just posing to the office gathering today. Thank you very much.
Thank you so much, sir. I would now like to invite Shri VP Adam G, Scientist F, CPCB, to say a few words.
Thank you. First of all, I would like to thank ICEA for organizing this program and inviting me to share a few words with you. I also thank the Accenture Group for preparing this report and highlighting various critical issues along with the availability of critical material. मुझे याद आता है जब फर्स्ट टाइम मेरा इनसे इंटरेक्शन हुआ था एक्सेंचर ग्रुप से, बहुत सारी चीजें हम लोगों ने डिस्कस की और मुझे खुशी है कि वो सारी चीजें उन्होंने अपनी रिपोर्ट में डाली और ये सब चीजें जो उन्होंने रिपोर्ट में डाली है, तो उन्होंने शॉर्ट समरी मुझे दिखाई। रिपोर्ट पढ़ने के बाद मैं इस पे अपना कमेंट जरूर दूंगा, लेकिन एक चीज जो मुझे थोड़ा सा हिट की, they have given the figure that about 30% waste is not being collected. सर, आप मुझे कहीं भी लिथियम आयन बैटरी का डंप नहीं दिखा सकते। लिथियम आयन बैटरी कहाँ पड़ेगी? It is being collected. It is being processed in unorganized. ये जो डेटा अपने शो किए only 0.4 टन और जो भी साइकिल में आया, ये पूरा ऑर्गेनाइज सेक्टर का ही स्टडी है। और जैसा कि हमारे बाकी वक्ताओं ने, वर्मा जी ने भी कहा कि एक बहुत बड़ा सेक्टर ऑर्गेनाइज सेक्टर का है, जहाँ की बहुत सारी चीजें प्रोसेस होती है, उनको भी हमें अपनी मेन स्ट्रीम में लाना है। और आई थिंक दीज अनऑर्गेनाइज सेक्टर आर मोर ऑर्गेनाइज्ड देन ऑर्गेनाइज्ड, क्योंकि हम लोग बात करते हैं वो उस इकोनॉमिक्स में काम कर रहे हैं जहां पर कि उनको उसमें प्रॉफिट हो। और जहां तक रिसाइकलिंग की बात है, मैं बिल्कुल मैं बात करता हूं कि जब तक रिसाइकल्ड मटेरियल रॉ मटेरियल से सस्ता नहीं हो जाएगा तब तक कोई यूज नहीं। ये बेसिक इकोनॉमिक्स, हम चाहे जो रूल लगा लें, चाहे जो भी हम अपने इम्प्लीमेंटेशन में या स्टेट बोर्ड के थ्रू या सेंट्रल बोर्ड के थ्रू या नीति आयोग कोई भी कैसी कर ले, मैन्युफैक्चरर को जो मटेरियल सस्ता मिलेगा उससे अपना प्रोडक्ट बनाए, उसको हम कंट्रोल नहीं कर पाएंगे, चाहे वो क्वालिटी के नाम पे कहे, चाहे जिसके नाम पे कहे। और मेरी अभी कुछ 2-3 दिन पहले ही बैटरी मैन्युफैक्चरर से बात हो रही थी, दे आर स्ट्रगलिंग विद द रॉ मटेरियल। मैंने उनसे पूछा, आपको क्या जो रिसाइकलिंग यहाँ पर हो रही है जिस स्टैंडर्ड में, क्या आप वो उस मटेरियल को यूज कर सकते हैं? उन्होंने बिल्कुल मना कर दिया। सर, अभी हमारा वो स्टेज नहीं है कि हम ये रिसाइकल्ड मटेरियल को अपने प्रोडक्ट में यूज करें। आई एम टॉकिंग अबाउट द लिथियम बैटरी। लेड रिसाइकलिंग बैटरी का हमारा इकोसिस्टम मैच्योर हो चुका है एंड हैप्पी टू शेयर द इंफॉर्मेशन विद यू। More than 75% of lead is being recycled in India. कुछ ही परसेंट हम जो है रॉ मींस लेड हम इंपोर्ट कर। और आज हमारा लिथियम आयन बैटरी का इकोसिस्टम अभी डेवलप हो रहा है, हमने अपने पोर्टल भी बना दिए हैं, लेकिन अवेयरनेस की जहां तक मैं बात करूं, इतने मीटिंग इतने सब कुछ होते हुए वी हैव अराउंड 4000 मैन्युफैक्चरर इंपोर्टर और ये हमारे रजिस्टर हो चुके हैं हमारे पोर्टल पर, लेकिन इस साल केवल अभी 1000 लोगों ने ही केवल रिटर्न फाइल किया। क्योंकि जब तक हम आपको हम मॉनिटर नहीं करेंगे, हम किसी भी चीज की इम्प्लीमेंटेशन नहीं करा पाएंगे। मेरा ये कहना है, जब तक कि सारे स्टेक होल्डर्स, मैन्युफैक्चरर, रिसाइकलर हमारे पोर्टल पर आ नहीं जाएंगे, हम उनको मॉनिटर नहीं कर सकते। क्या टेक्नोलॉजी यूज कर रहे हैं, वो ब्लैक मास कैसे जनरेट कर रहे हैं, किस क्वालिटी का जनरेट कर रहे हैं, कहाँ एक्सपोर्ट कर रहे हैं, ये तो बात की बात है। ये हमारे भी दिमाग में था कि जब तक हम ब्लैक मास को हम कंट्रोल नहीं करेंगे, तब तक हमारे मैन्युफैक्चरर यहाँ पर सेल्फ रिलायंट नहीं होंगे, तब तक वो इंपोर्ट पर अपने काम करते हैं। आज जैसे जो सिचुएशन इंटरनेशनल लेवल पर हो रही है, रॉ मटेरियल एक क्रिटिकल इशू बनने वाला है। उसके बाद फिर जो भी हमारी प्लानिंग है उसको हम कैसे सस्टेन करेंगे, इट इज क्वेश्चन। तो मेरा ये कहना है कि आज बहुत खुशी है कि सब एक प्लेटफॉर्म पर हैं, इंडिया रिसर्चर्स, IT, तो हमको कुछ वायबल सोल्यूशन जो कि हम अपने इंडिजिनियस टेक्नोलॉजी अपने यहाँ डेवलप कर पाए। CSIR लैब्स आर ट्राइंग, कई प्रोजेक्ट्स चल रहे होंगे बैटरी मैन्युफैक्चरिंग के ऊपर, यूज ऑफ रॉ मटेरियल के ऊपर, इसकी रिफाइनिंग के ऊपर, लेकिन अभी कोई बहुत पॉजिटिव वे में मेरे पास कोई रिजल्ट नहीं है, सो दैट आई कैन इम्प्लीमेंट। इम्प्लीमेंटेशन में मैं अपने रूल में उसको डालता हूँ या स्टैंडर्डाइज करता हूँ किसी चीज को, पर्टिकुलरली कि रॉ मटेरियल की क्वालिटी क्या हो, किस टाइप का रॉ मटेरियल यूज होगा, कैसे होगा, कितनी क्वालिटी होगा। एक चीज मैं आपको और बताना चाहूंगा कि मिनिस्ट्री ऑफ एनवायरनमेंट एंड EIS has gone a step ahead. Now we are thinking about the eco labeling on the bed. अभी कल ही मीटिंग थी तो हम लोगों ने डिस्कस किया इको लेबलिंग के लिए हम क्या स्टैंडर्ड है जिसके ऊपर आपको इको लेबल दिया जा सके। तो वो चीज में भी हम फ्रेम कर रहे हैं कि रिसाइक्लेबिलिटी जैसे भी हमने अपने रूल में डाला है कि मिनिमम 20%, 30%, लेकिन हम जो इको लेबल हमारा प्रोडक्ट होगा बैटरी का, सडनली वी विल गो ए स्टेप बैक। हम 20% पे कॉम्प्रोमाइज नहीं करेंगे। उसकी एनर्जी डेंसिटी क्या हो, उसकी लाइफ क्या हो, ये सारे फैक्टर्स में निकल के, क्योंकि जब तक बैटरी की लाइफ नहीं बढ़ेगी अल्टीमेटली वही चीज आ जाएगी। हर चीज एनर्जी के ऊपर डिपेंड कर रही है, कितनी मिनिमम एनर्जी से मैक्सिमम आप उसकी आउटपुट ले सकते हैं। तो बहुत सारी चीजें हमारे दिमाग में भी, इम्प्लीमेंटर के दिमाग में है, रेगुलेटरी एजेंसीज के दिमाग में है, पॉलिसी मेकिंग के है, रिसर्चर के हैं। हम सबको एक प्लेटफॉर्म पे आके काम करना पड़ेगा ताकि हम अपना ऑब्जेक्टिव अचीव कर पाए। तो लेकिन बहुत अच्छा लगा आप लोगों से मिलकर, और आपके दिमाग के कुछ भी इश्यूज हों, वी आर ओपन टू डिस्कस इट विद यू। थैंक यू मैम।
Thank you so much, sir. Our last speaker of today, Ms. Yogita Puri, scientist in CPCB. Please, if you could share a few words.
Thank you. First of all, good afternoon all, and thank you ICEA once again on behalf of CPCB to invite us and to discuss on such an important issue uh, for this specific type of industry. And before saying any further words, I would like to congratulate on for coming up with this report, which indicates a very important key indicators, which are very important. The data, which is very important, which for which we are always running behind people, which data is correct, and to plan the future, to plan the technologies, and to plan the requirements as a regulatory body. So, congratulations, sir, to the entire team. Now, since I'm the last speaker, we have heard a lot about very good important points, findings, which is important for this particular topic, lithium-ion batteries. We know the demand, we know the consumption, we know the requirement, and we know that how much it's important for the industry. And we also know at the same time, thanks to the Ministry of Environment, ICEA and India Cellular to come up with certain scheme which also talks about the recycling of this entire waste stream, the recycling of e-waste, recycling of battery waste, and battery waste was also being regulated with the previous notification, which was limited to a specific type of battery. Only that acid batteries were there. But now we have a very detailed and very varieties are there. Every battery is covered under the rules, and we know the regulations. We know what stakeholder needs to perform what. So, see, we have talked about the requirement. We talked about the the graph which we are seeing everywhere, which chemistry is going where, and as Amit sir has also mentioned about that, we have to be ready for any kind of future chemistry which will be there, which might be there for the betterment of any equipment which may, which you all must be willing to use that chemistry for their products. But yes, at the same time, and being an environmentalist, being a regulatory body, we should also be ready for the challenges and their respective solutions. So we are trying. I mean, CBCB, what we are doing, you all are aware about. Uh, Slowly, we are also learning, and parallelly, we are coming up with the solution as well. We have PR is a big thing and big support to the recycling industry, we all know. But it is not only one-sided game. You better understand the overall regime, the overall ecosystem of APR. I will not speak much on this. I just want to touch a small point on the critical minerals and the scheme which we have. So what government wants to say and what is our agenda with that? So there are many specific and the agenda is very clear and cut to cut. So see, we want to restore. We want to have the critical minerals available within the domestic framework of our country. So definitely, and we do not want to depend on other countries when we are talking about the availability of the resources. And yes, somebody was saying that black mass should be, and it is indicated in the report also I was studying that black export of black mass should be banned and it should be recycled within the country. So where is the preparedness? So we have to see the availability of the infrastructure. What infrastructure do we have? What is the requirement and how much requirement will be there in the future? We know the demand by 2030. We all know that it is indicated in the report in the slide also. It was Sandeep ji was mentioning that 150 gigawatt is the demand. So we should be ready with the recycling infrastructure as well. So the CMM objective, what is the objective and how we can achieve that objective? Very simple. It is very simple. It will start from the like secure our supplies. If we are reduce the dependency on the import of the things. Channelization is very important. So you all are into that area where you are producing the products and with the products are reaching out to the consumers. Where is the channelization of the, see, it is mentioned in every waste management rules that certain responsibilities have been given to the producer, that you have to perform your duties and you have to meet your targets. But how will you meet your targets? So there has to be certain planning methodologies should be available at your end, and we should talk about the channelization of waste as well. See, when you are making plan for channelization of flow of that product into the market. Similarly, we have to sit on a table and plan stabilization of this entire waste. We cannot and we should not depend entirely on the recyclers, that they will perform on our behalf. So you all are big brands. You have the support, you have everything. So why not this? So channelization is very important of the waste, entire waste flow, where waste will start from consumer. How will I, as a consumer, I should know where my waste should go.
Hello.
Next is just energy transformation and energy transition. I mean the use of solar energy, use of wind energy, and EVs we have around us everywhere. So that also the very important step from the government. It was very important for our society to take care of the environment as well, and also which will support the entire country when we are talking about the restoring our resources. Next and the very last topic is technology. So ma'am was mentioning about the availability of the new technologies and research which is going on. Not only for the manufacturing of new products, new electronic items or new vehicles, but yes, we are also taking care of the technology for the recycling. How we can really achieve those elements which are not at all listed anywhere in any of the document or government policies or guidelines. So Sandeep sir was also at the last he was trying to say that we should not only focus about the 10 or 11 in the field of battery or 4 in the field of e-waste identifying materials. We should also focus on the other elements which are equally capable, important, and we cannot just throw them anywhere and I'm sure with the data and with the research, we can say that those elements are important for the country, for the nation. If we really want to achieve the you know, increasing graph for the industry, and so this is it. So I will not speak much. What is EPR and how it should be implemented? We all know. So this is a kind of support system we are giving to the industry. And let me tell you that this is not only for the recyclers. Yes, it is equally important for the producers as well. So thank you so much for having me here. And once again, big congratulations for this study. Thank you.
Thank you so much, ma'am. I will now request our chairman, Shri Pankaj Mohindroo ji, to honor our distinguished guests with mementos as a token of our appreciation. Shri Sandeep Singh, Managing Director, Accenture Strategy and Consulting. Shri Amit Verma ji, Director, Circular Economy Cell, Economics and Finance Cell. Ms. Sunita Verma ji, Science and Group Coordinator, Ministry of Electronics and Information Technology. Dr. Sandeep Chatterjee, Senior Advisor, SERI. Shri V.T. Raghavji, Science Cell, CPCB. Ms. Yutika Ori, Science C, CPCB. Thank you so much, sir. On behalf of ICA, we extend our sincere appreciation to all dignitaries, speakers, guests, and partners who have joined us today. We hope that this report will serve as a meaningful guide for industry, policymakers, and stakeholders in building a common, scalable, and sustainable lithium-ion battery recycling framework for India. As we draw this important session to a close, I would now like to invite Dr. Ashish Sarakia, Director of Public Policy, ICEA, to deliver the vote of thanks.
Thank you, Shambhavi. Basically, this report was, the purpose of this report. Largely at ICEA as an industry body, we are always working for increasing and encouraging manufacturing in India while ensuring sustainability. So we have to keep both things side by side. We always are like, I would like to thanks to all dignitaries on the dais, especially Sunita Verma ma'am and Yuthika ji, Yadav ji. It is my experience as a policy professional representing ICEA. The gates are always open for the industry to listen what is relevant, what is not relevant, and how procedural ease and policy ease can be ensured. So, again, great thanks to Sandeep ji, Amit ji, Sandeep Chatterjee sir, Sunita Verma ma'am, Yadav sir, Yuthika. And thanks for the audience and media friends who are there. Thanks. Thank you.
If anybody would like to ask any questions.
My question is, anyone can answer that, especially CPCB. I find in the RTI a year back about the data of waste monitoring and lithium-ion batteries. But that data was not there, and I was only told that all it is done as per rule number the census. So can you tell me where are the gaps that CBCB lacks collecting data from the industry with the lack of coordination of the industry with the lack of willingness. If you can point out the gap, what is being done to address that?
I didn't get the appropriate reply, but this gap when we're talking about the data. We are still and daily the data, it's a very dynamic data. So whatever industry is giving us, we different modes of whether we are receiving reports, whether we are receiving the portals. Nowadays we have online portals where the digital industry can submit their information or data directly to CPC. There is no need that state government will compile the data and just so data is there, and I'm not sure about why didn't you get the specific information on the waste generation, because it is very much available at the departments, and if you can submit your query, then you will definitely respond. Is there any specific you want to ask?
They say that even the companies are giving up their product for recycling to unorganized sector because there is low cost. So there is a gap where it is not coming to the organized players, it is going to unorganized players. Are you doing anything to monitor these things? Is there any feedback that you have, and you think the gap is being left there also?
Yes, definitely. This entire regime of EPR is for that for making that gap only. And coverage of this rule, and how recyclers are getting support from the recycling of these industries. They were running their businesses even before these rules as well. But now we have a proper framework which also facilitates them from, while they are performing their duties for the collection, for the transportation, as well as for the recycling. So that we want that e-commerce sector comes into the picture, and they can also avail the benefits of this EPR regime. I mean, they are selling their products, but they are also getting the benefits of this EPR from the stakeholders.
Industry is not giving any product to informal sector. I don't know what is your source of information. Industry doesn't own any product. A product is sold to the trade, then it is sold to the retailer, or it is sold on e-commerce, and it goes to a consumer. So where is the industry handing over to the informal sector? This is a bizarre comment, Krishna.
So the collection responsibility lies.
Who has given you this information? What is your
That I cannot reveal, but it is from the industry and from the e-waste recyclers.
That the
consumers lies on the company because it is part of India.
How can you hold a company responsible for what the consumer is doing? There are 900 million consumers of mobile phones. Is the industry responsible? Don't make irresponsible.
The collection responsibility lies on the companies as part of EPR. And they should have that mechanism in place to collect those goods.
It is an impossibility. Industry in a market which is fragmented and which is not controlled, the product is not controlled, can never control it. How will you control it? How is it possible to control it?
It's not a rocket science. I can say, if I am at that chair, I can tell how can it be controlled. But I am sitting on this side of the chair.
900 million products the industry can control where the consumer decides to give the product without a legislation. Fantastic. I have no more comments to make.
I think that's all for today. I would request everybody please join us for lunch. Thank you.